Okay, so let's do part B. I want to point out something that might be useful. I showed you these two loops in the first video. You can actually make this 3 loops, and I'm going to do this because I think it'll make something a little bit clearer. I'm going to make the whole thing 1 loop. I'll call that loop 3. So keep this in mind. I just put the 3 because that's loop 3. Loop 1, loop 2, loop 3. Alright, so this says B, calculate the charge on the 10 microfarad capacitor. Remember, this is after these are completely charged and your current is stopped because your capacitors are fully charged and the current doesn't have anywhere to go except through the capacitors, and yeah. So anyway, I went ahead and drew this loop. I just isolated it. Here's your battery, it's 30 volts. Got your 40 ohm resistor and your 10 microfarad capacitor. So let's analyze this to calculate the charge on the 10 microfarad cap. Now remember from the lovely musical performance that some of y'all did in class, well, for second period, that caps are quite Q, which would be your charge, overvalued. Over voltage, you could put, if you put the delta V, that's potential difference, you could, I guess, put sigma, or not sigma, epsilon, that's, you know, the curly E, that's EMF. There's lots of ways you could put that. You should know that by now, but C, Q over V. Now, you are going to need to solve for the Q. So that would mean 4 Q equals CV. Quick note on this. The capacitor one that involves like the distance between the plates and the area, that's what you'd use to figure out like physical things of the capacitor. If you have capacitors you need to add up, you'd use your 1 over C equals 1 over C plus, you know, etc. for series and just add them up for parallel. This one, whenever you're dealing with just how it behaves in a circuit, this is usually the one you're going to use. It's like your voltage equals current times resistance for, you know, other types of components. But anyway, you know your capacitance already. It is 10 microfarads. Mu, that's mu, and that's micro, 10 to the negative 6. Okay, and you're going to want to multiply that times your voltage drop across your 10 farad. This would be a voltmeter. We don't know what it reads. 10 farad cap. Now, this is where the loop comes in handy. Remember, this is just one big loop. I called it loop 3. And so that means if you put, just no matter what was going on, you have this plugged in, it's in steady state or whatever, your current should, for both of these components, look at where I put my voltmeter, should equal 30 volts. Now, this is a special case because we already said this is fully charged because it's been plugged in a while. Current equals 0 from part A. So that means that you got a different situation going on here on your 40 ohm resistor. As I just mentioned, you have voltage. This is for a resistor, for fans, for light bulbs, anything like that. Equals current times resistance. This will tell you what's going on. Or you can think of it in other ways, like current is directly proportional to voltage, inversely proportional to resistance, like the human circuit model we made. So you have this, and look, I is 0. So that means all of this is 0. Effectively, like, nothing's happening here. But of course, the reason nothing's happening is because both of these plates are charged, which means you have a potential difference, also known as voltage, across your capacitor. And that potential difference, since we're pretty much ignoring this, we could like, I'm just going to scratch that out. Let's ignore that voltmeter and look at the one I drew here. That means that the reading across your capacitor is your full 30 volts, according to the loop rule. So that should be useful. So you're going to have 10 times 30 volts. And that means that your charge should equal 300. Wait a second. Now, you can go and rearrange these. Don't. It's too big of a pain. You know, hopefully, that charge, think about Gerardo or Demas, is a coulomb. In this case, though, we wouldn't just put coulombs because you have your micro. You just put micro, which is 10 to the negative 6 coulombs. So that is the answer to part B. Right there.